Good morning, class. So at this point we're looking at functions, our last lesson before your exam. So you will be writing on the whole year's work up until this point here. Okay. We're giving you the breakdown as well. Did I give you homework for today? Yes. Okay, the homework was exercise 5.5. Okay, we'll start there. We're looking at exercise 5.5 on page 27, number 3. Okay. So we are told sketch the graphs of y equals x plus 3 all squared minus 4 and y is equal to on the same set system of axes. So if we do that, then we know the graph will have a turning point at negative 3 and negative 4. Not so. There's negative 3 and negative 4 is approximately. Oops. Okay. There's a y-intercept where x is equal to 0 of 9, 5. Not so. So I'm just going to put this point a bit higher. Okay. Okay, so this point here is there. Okay. Okay, what is your x-intercept? Sorry? I'm just going to redraw that. That's a very good representation there. What is your x-intercepts? Sorry? Negative 3 and negative 2. Huh? What? Negative 3. How can it be negative 3? Negative 1, that sounds more like it is. So how can you cut a negative 3 if it's turning at negative 3? Okay. Will I show you how I got negative 5 and negative 1? No. Now why are you giving me the wrong answer? Oh my word. Sound like we didn't do your work. Okay, but anyway. So that is the equation of the parabola. I'm just going to label it there. Y is equal to, open brackets, x plus 3 squared minus 4. Then you got the straight line, which is y is equal to negative 2x minus 7. Your x-intercept is negative 7, which is lower than that turning point there. And you have an x-intercept, a y-intercept of negative 7 and an x-intercept of negative 3.5. So it's going to cut approximately there. So again we take a ruler and we draw the line. Okay, that is not a very good start. We have put the point first. But that's what you have there. Not so? So let me bring this up a bit to show you a couple of questions that we will have. Okay, so and this is the equation. Y equals negative 2x minus 7. Okay, so the question says calculate the points of intersection of the two graphs. So there are 2 points of intersection. There is one and there is one. Not so. How do you work out the points of intersection? You said the 2 graphs equal to each other. Not so. So it's going to be x plus 3 squared minus 4 is equal to negative 2x minus 7. You multiply this out, I get x squared plus 6x plus 9 minus 4 plus 2x plus 7 equals 0. which gives me x squared plus 8x plus 12 equals 0. So that gives me x and 6 and x and 2 plus and plus. Not so? So x is minus 6 or x is negative 2. But I haven't answered the question. No, we need the corresponding y value. So what I do is I substitute it into the equation of the straight line. It's easier, or if you go with the parabola, is no problem. It's going to be 12 minus 7, which is 5. It should give you the same answer in either case. Y is then equal to negative 2 times negative 2 minus 7, which is negative 3. So the coordinates is negative 6 and 5, or the other one is negative 2 and negative 3. There's going to be negative 2 and negative 3 there, and negative 6 and 5. Does it make sense of where it's lying in terms of the coordinates as well? Yes, it does. So if you look between negative 3 and negative 1 is the point of intersection. But you couldn't just guess it's negative 2. Okay? They're going to be safe in that case. Alright. Now, the reason why I wanted you to do this is, part of the reason is so that I can show you the following. Okay? If the question was, where is f of x greater than and equal to g of x? That's one question we're going to answer. B, we would like to know where f of x times g of x is greater or equal to 0. C, I would like to know where f of x over g of x is greater or equal to 0. Now just coming here, you'll ask now, where is f and where is g? Okay? I'm going to let the equation of the parabola be f of x, and the equation of the straight line be g of x. Okay? So this is your f, and that is your g. Okay, I just made that now. We could have made the parabola g and the straight line f. It doesn't matter. Okay? I'm going to answer the questions the same. Okay? So you answer those 3 questions for me quickly. Okay? I'll give you 2 or 3 minutes. I'll pause the video at this point, and then I'll explain how far off are you or you're spot on. Alright, the first one, where is f of x greater than or equal to 0? Where do you find that? In other words, it is where? The f of x graph is more than the g of x graph. The f of x graph is greater than the g of x graph. So looking from on top, okay, there's your pretty eyelashes, looking from on top. Oops. Cross like that, okay? Where is f of x more than or greater than the g of x graph? Greater than or equal to? So it's this part here, not so. So it's in that direction. So what do we say then? X is less than and equal to negative 6. Okay. So here g of x is greater than the f of x graph, all the way down. Not so. And that's not what I want. Okay? Then again, the f graph is on top of the g of x. Can you see that? And where is that the case? For x is greater than negative 2. You all understand that? So we say, or x is greater than equal to negative. Let's look at the next one. Where is f of x times g of x greater than or equal to 0? What does that mean? That means to say, okay, greater than or equal to 0 means what? It's positive. Where is it positive? When we're multiplying two things. When we're multiplying two numbers, under what condition will it result in a positive? A negative times a negative, or a positive times a positive. Okay. So the f of x graph is positive if it's above the line, or the g of x graph as well is positive above the line, and below the line it is where it is negative. Not so. If this had to be the other way around, then I would have said where f of x times g of x is less than or equal to 0. Under what condition will it be less than or equal to 0? If one is positive and the other one is negative, or the other one is negative and the one is positive. So, in this case, and in the exam they won't ask you both. They'll ask you one of the two or none. Okay. So, looking at this here, both graphs must be positive or both graphs must be negative at the same time. You guys understand? So again, looking from left to right, we read out domain and our range from left to right. We read from your increasing and your decreasing from the negative part to the positive part, from left to right or from negative to positive. Likewise, these inequalities, we read it all from left to right or from negative to positive. Okay. So the question says, we established that both must be negative or both graphs must be positive at the same time. So what we notice here, what are you looking for? There isn't. You're making a noise. Okay, so you all agree that from this side, what do you notice? Both is positive. Not so. So why you come now? Sorry about that. So, on this side here, what do you notice? Both graphs is positive. So which point is both graphs positive? Huh? You can't see, okay. So what we do is, you can take a ruler. Okay? Take a ruler. You say, okay. Take a ruler on the side. Will both graphs be positive here? Yes, because both is going up, he's cutting this. So both will be above there. So you move over. Is both positive? Yes, yes, yes. So which point is both positive? Till 5. Negative 5. Can you see that? On the other side of negative 5, one is positive and one is negative. Can you see that? You all understand? So it's positive where? For x is less than negative 5. So it's less than. X is less than negative 5. Is one of the graphs equal to 0 to result in a 0 at that point? Yes. So I'll include negative 5. You all agree with that? Okay. Or what happens on the other side, negative 5? One is negative, one is positive. Not so? To which point does it change? Negative 3, 5. Negative 3.5. Negative 7 over 2. Can you see that? Why? Because from negative 7 over 2 till which point is that the case where both is negative? Till negative 1. Can you see that? Both is below the line here. From that point, you see both is below. So hang on. One is above and one is below. You guys understand? So is that the continuous or breaking solution? Continuous. So that part must be written together. From which point? It's going to be written together from you see at this point, what do you notice? They are one positive, one negative. Not so. From negative 3.5 until negative 1, both is below the graph. So both is negative. Can you see that? On the other side of negative 1, one positive, one negative. You understand? So it's a continuous solution from negative 3,5 until negative 1. Is one of the graphs equal at negative 3,5? Yes. At negative 1? Yes. So there we go. Will that answer? X is less than or equal to negative 5, or x is greater than or equal to negative 3.5, or x is less than or equal to negative 1. Alright, let's look at the next one. The next one, C, it says where is f of x divided by g of x greater than or equal to 0? Okay, so what I'm going to do is I'm going to change this around, spice it up a bit. Otherwise it's going to be a very similar answer to B. Okay, so is it okay if I change it? Okay, even if I had said no, I would have changed it anyway. Okay. So, looking at f of x over g of x, where that is less than or equal to 0. What does less than or equal to 0 mean? It's negative. Under what condition when you divide in two numbers will it be negative? Positive divided by negative, or negative divided by positive. So in other words, to us, it is where the one graph is above the x-axis and the other one must be below the x-axis. Not so. One must be above and one must be below. Alright. So looking here, again, from left to right. Whoops. Looking from left to right. One must be above and one must be here, both is above. We started off with covering. What are you busy with? You're showing her this work. Now can I show us all? So all of us can benefit. What are you showing her? Sorry? She wrote it down. So she's showing you, she wrote it down. Everybody has to write it down. So try again. What is she showing you? Can't you see? Then why are you sitting so far? Isn't the seat right here, my girl? Does that make sense? You sit there at the table, there, there. But now you sit where you can't see. Doesn't make sense. Okay. So move. So what do we see here, people? Both is positive. What do you notice here now? One is above and one is below. Can you see that? It is between which 2 points? Is that the case? Negative 5 until negative 3.5. Oh my word, you just moved one seat closer to the girl that we're talking to about. Sit here. Sure? No, I don't want you to see from there. Okay. Can you see, people? One's above and one is below. No? Right. Is that a continuous or break-in solution between negative 5 and negative 3.5? Is it together or apart? It's together. It's a continuous thing. No? So x is greater than negative 5 but less than negative 3.5. Let's see here. Is there another case like it? Yeah, what do we notice from negative 3.5? Both is negative until negative 1. Can you see that? From negative 1 onwards, one is above and one is below, all the way to infinity. Do you guys understand? So, in other words, x has to be greater than negative. You all agree with that? Now coming back to, there's an equal sign. Yes? Ask.
I'm a bit confused with why can't you say from minus 5 until minus 1? Like,
okay. She's asking why can't you say it's a continuous solution from minus 5 to minus 1. But if you look from minus 5, here one is above, one is below. One is above, one is below. What do you notice here? Both is below. You see both is cutting here. Below this line. So both is negative. We're looking for where one is positive and one is negative. Not a O, man, it's a X. Okay, so one above, one below. Till there. In which one is above and one is below that axis, the x-axis. But coming back to, there's an equal sign there. You see that? Now, is one of the graphs equal to 0 at negative 5? Yes. So can it be equal to 0? Yes. So that means your f of x. At negative 3, 5, can I put an equal sign there? It's equal at 0 here, not so? But why am I going to refrain from putting a 0? No. Not both negative. One is 0, definitely. But g of x is 0 there. Can you see? But what is g of x? G of x in your denominator is. Can your denominator ever be equal to 0? No. Why? It will be undefined. The sum is undefined. The sum is not going to work for us. Not so. Not going to be a solution. So that means to say I'm not going to put the equal sign. Okay? Can I put the equal sign in negative 1? Yes. And there we go. Alright. A lot to take in at one point, no? Normally we just don't teach this. We need to learn it. Figure it out on their own. Yeah? But you guys must now, I think you guys want to do well and all of these things. I'm teaching it to you, okay? But sometimes I think I'm wrong. I am. Did you say I am wrong? Huh? You are wrong, you said.
No, we said
Huh? You said what? What did she say?
You said ah.
Ah, why?
She got it. Oh.
Okay. Right, people, let's do this. We just go a bit quicker through it. Number 4, you're drawing a graph. It's a maximum graph. It's starting at 3 and 2, so I need to bring this over a bit. X is 3, y is 2. So we have a y-intercept at negative 9, negative 16. Is that correct? So you have a y value of negative 16.
Yes.
Okay. Make it look negative 16. It doesn't look very much better. It looks lopsided, but you guys get the idea, no? It should be symmetrical about this line here. I don't have time now to draw and all that nicely and those things. Right. Then we have the g of x graph, which is going to cut at negative 10 and has a y value of x-intercept, sorry, of 5 over 2. So 5 over 2 is approximately there. Not so. What I do is I draw this line with a ruler. As you see me doing that. Right. Again, we're going to make this, or it is labeled f of x and g of x. So that is your f graph, and this is your g graph. Okay. You all okay with that, people? Okay. First question pertaining this graph that follows is calculate the points of intersection. How do you calculate the points of intersection? Say the two graphs equal to each other. Not so. So we're going to have negative 2 into x minus 3 squared plus 2 equals 4x minus 10. So it gives you negative 2x squared. That's going to give you minus 6 is plus 12x minus 18 plus 2 minus 4x plus 10 equals 0. So it's going to give you negative 2x squared plus 8x minus 6. Okay, divided by negative 2. So I get negative 4x plus 3. That gives me two solutions on x and x, 3 and 1, minus minus. So x is equal to 3 or x equal to 1. Have I answered the question? No. We need the points, so the coordinates. The corresponding y value by substituting that back. So g of 3 is equal to 4 times 3 minus 10, which is 2. And g of 1 is going to be 4 times 1 minus 10 is negative 6. So the coordinates of the point of intersection is 3 and 2 and 1 and minus 6. Okay, that's 1 and minus 16. And that's going to give you 3 and 2. What does that mean? That means to say that this graph is actually going through the turning point. Can you see that? I can't pick up this finger. So that's actually what's happening. Okay. Again, the graph is not drawn to scale. Okay, now it looks like that x-intercept of both is the same, but it's not the case. No? Must be probably very close. Very, very close. Okay. So that is 2.5 then. What was your x-intercepts of this graph?
2 and 4.
2 and 4. 2 and 4. Okay, it explains it's very, very close. Okay. Again, doesn't give, doesn't justify why the graph is drawn so ugly. But okay. We're not actually going to pick it up very well like this. Okay. The questions pertaining to this graph again. Write down the domain and the range of f. The domain of this graph is x an element of all real numbers. The range is y is less than or equal to 2. Then the range and the domain of g. The range is y is an element of all real numbers and x is an element of all real numbers for that graph. I'm going to take one more shot at this. That looks a bit better. The coordinate was 1 and minus 6, nah? And 2 and 3. And we said it's going to be 2 and 4. Alright. Let's go with this graph instead. Alright. First question. The question is, where is f of x greater or equal to g of x? I'm going to go a bit faster through this. So f of x is that graph and g of course is that graph. Where is f on top of g? Is f on top of g here? No. Here? Yes. It's a continuous solution from 1 till 2. That is the only place. On the other side of that point of 2, g is on top of f. You all agree with that? So it's a continuous solution from 1 to 2. So how do we write that? So x is greater than or equal to 1 but less than equal to 2 because are they equal at that point? No? 3. This is 3. Does not be greater or equal to 3 because I'm seeing the 2 there as well. Okay, my mistake there. The next one says where is f of x times g of x greater or equal to 0. What does that mean to say? For something to be greater or equal to 0, both must be positive. or both must be negative. Okay. So if we look at this graph, what do you notice? Looking from on top here. Will you put the eyelashes? Go again. Looking from on top, what's on top? It is your g of x. On top all the way till this point here. Not so. Both graphs, positive. Both graphs must be positive, which means to say both must be above this line. Okay? Or both must be negative, both graphs must be below the line. So looking from this here, again let's bring out in our ruler here. Looking from a vertical line. Looking from here. Is both graphs above or below? Yes, they all start out below. Below, till which point? Till 2. You see then? And then one is above, one is below. So in other words, x must be less than 2. Can it be equal at that point? Yes. There's no restriction on this one. In that form. Let's look at this side. What do you notice here? One is above and one is below. Can you see that? It's a very slim section there, but it's from 2 till 2.5. That's why I needed that point. Okay? But from 2.5, one is above. Sorry, both is above. Both is above till which point? Till 4. Can you see that? So if you write that as an inequality, you say, or it's a continuous solution from 2.5 till 4. That's the case. Okay. Okay, and then the next one again is where f of x divided by g of x is less than or equal to 0. So one must be positive and one must be negative. So we already established on the side of 2, it's not going to be the case. However, it's from 2 till 2.5. It's very small. So x is greater than 2 but less than 2.5. Where else is that the case? From 4 onwards. Okay. Or x is greater than 4. Now, the denominator can't be 0. And what is the denominator? The straight line graph. The straight line graph is 0 at 2.5. So that is going to give you
Can I have everyone's
equal,
attention, please?
not equal,
Good
and
morning.
equal.
Can I have everyone's attention? Can everyone start packing up their bags, please? Please put all your belongings in your bags and then wait for further notices. Everyone, please put your belongings in your bag and wait for further notices.
No, you guys are not going to wait for this even. Right, people, that is basically the end of it. Before you write your exam, all the best for the exam. Okay, and please this time, yes, make me proud. Yes, okay. Enjoy the day and the rest of the weekend, and all the best for the exam.